Thanks everyone for coming to this talk. So I'm going to be talking about sustainable continuous delivery. So kind of the dev part that Damon in his great talk was talking about. But I think that's not the whole story, because when we're looking at the pipeline or deployment practices, there's always a lot of things that we can do to improve how we're able to then respond to problems and ensure certain aspects of how we're able to fix problems in production. And the other thing I want to mention is that in a lot of clients that I see, they're not saying go, go, go. They're actually saying whoa, 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 calm down, slow down. You're trying to do things too fast on the delivery side. That's more the pattern I see. So I'm Manuel Pais. I'm an independent DevOps consultant and trainer. And I usually like to focus on the flow of work in the organizations and how the teams are organized before we look at the tools and the practices. So I don't know if anyone is familiar with the DevOps Topologies website. Anyone knows the DevOps Topologies? Okay, so it's a catalog of how to structure teams, and like Damon was talking, there are different ways that we can organize our teams with the same results. So it depends on the context. So I co-wrote the book Team Topologies with Matthew Skelton, where we talk about this in detail. But today it's about releasing and how to make releases safer or more reliable and faster. So this is the agenda. I'll explain what I mean by boring releases first. I'm sure everyone is excited when we talk about boring releases, right? Yeah, that's what we want. Actually, I think that's what we should aim for. Releases that are predictable, that we are not expecting constantly having to fix issues or find out how do we do this thing that we did 2 weeks ago, but now we forgot because it's not implemented in the deployment pipeline. So I like to use the analogy of a supermarket shopping. Okay, so if anyone here, for the people here who have small kids, the first caveat is that if you go to supermarket with a small kid, it's never going to be boring, right? It's always going to be some kind of trouble. But if you're, imagine you've moved into a new neighborhood and you're going for the first time to a supermarket and you have a shopping list, and the first time is a little bit painful, right? Because you don't know where things are, so you have to go around maybe 2, 3, 4 times until you actually have everything you need, and then you go check out and you go home. Second time, it's a little bit better, but maybe there are some new items that you need that time that you still need to look around. So it takes a little bit of time, but it's a little bit better. And then third, fourth, fifth time, it just gets easier and easier. At some point, it's just as efficient as it can be, right? You go, you know where things are, you pick them up, put them in the shopping cart, and you check out, and that's it. So I think that's what boring releases should be like. This kind of predictability and knowing what's going to happen, when's going to happen, and when it's going to get done. So I like how John Cutler puts it. If you're into any topics around product management, teams, motivational topics, I think you should follow John Cutler on Twitter. He's really good. And he talks about this low drama flow, where because there's no rush and things are predictable, we're not running around trying to find out how do I deploy this thing or how do I test it. It sometimes looks like we're not making progress. There's not all this adrenaline of, wow, we're making a deployment to production. And that's actually how it should be. This low drama is how should be the regular state of things. So when we have that, we can focus on the outcomes. Like if we're doing supermarket shopping, the outcome is maybe we're going to bake a nice pie or make a nice meal. We don't do the shopping just for the sake of it. We do it because we want to focus on this outcome. We want to focus on what we're providing to our customers, how well is it fitting their needs, what is the experience, and basically are we getting more value to users and making more profit for the company, hopefully. So for reliable releases or kind of predictable, safer releases, there are some patterns that I recommend, but I'd like to go back first to the definition of continuous delivery from Dave and just humble, so the textbook definition, the ability to get changes of all types into production or into the hands of users safely, quickly, and in a sustainable way. So I think sometimes we kind of overlook this as, oh, okay, that's kind of like the generic definition that makes sense. But if we look at each one of these aspects, I think we can get a lot of insights. So starting with safely or reliably. There's one thing which for me is really like it's a small step in terms of implementation, and it can be a giant step for many organizations. Just like the ones Damon was talking about, where you have all this kind of dependencies between teams, approvals, all these kind of processes that have been built in through time. One simple thing to start with is to map the value stream in the pipeline. What does this mean? Well, the value stream is a sequence of all the activities that actually take place to get a change or a feature from initial commit until it's actually in the hands of customers. So what tends to happen in large organizations is that any organization really that goes beyond 30, 40, 50 people, you start to have these dependencies, this kind of specialization that you need to get things done, and all the activities that are required to get a change from commit to actually being running in production make up our value stream. So if we can map that in our pipelines, then we increase the visibility of what's happening. What's the current status? What do we still need to do? Who needs to be involved, etc. And to identify the value stream, especially if you have a reasonable number of teams, the best way, in a simple way, is just to get people from different teams into a room and do what is called a value stream mapping exercise. So you just need a big wall, big pieces of paper, and people start writing down what are the activities that they perform and the sequence and more or less how long they take. And you start seeing the dependencies between teams and also start seeing what happens upstream and downstream from your domain of work. So for medium to large organizations, just doing this already raises awareness for a lot of people of what actually happens in a release. And you would be surprised how often people, the sphere of work, the things they have to do, whether it's development or testing or operations, and they don't know what else is going on in the release. So this alone can help identify a lot of bottlenecks and at the minimum raise awareness of what's going on in our release process. So if you don't take anything else from this talk, I hope that you try this at home in your company. And if you have a really long release process with many teams involved, you can also just start with a smaller number of teams, 2, 3, 4 teams, kind of around you, downstream or upstream from your work. And start to see what they have to do and what are the problems that they face as well. And I think this is the best example I've seen of this, is from Barclays. So what's happening, this was at the DevOps Enterprise Summit last year by John Smart. And so what happened at Barclays, they started focusing on Agile, like Damon was saying, trying to go faster, be more predictable, have 2-week sprints, I think. And they were really focusing on being agile. Yeah, every 2 weeks we can get something ready to ship. That's great. And then they started looking at all this stuff to the left and to the right of this of the development teams. So it turns out that there's actually 18 months period between an idea takes place or some business initiative. From the moment it started until it's actually approved, it's reviewed, and it goes into the backlog of development teams. So 18 months, and they were focusing on, no, 2 weeks is what we need to get to, or 1 month is too long. And downstream also, like monthly integration cycles and then quarterly releases. So even if a team was able to get something, this great feature ready in 2 weeks, but if they were at the beginning of a quarter, then it was still going to wait almost 3 months until it's in the hands of users. That's not fast. So he called this the urgency paradox, focusing locally on improving the speed of development where everything else upstream, downstream was extremely slow. Another pattern I think is very important are focusing on key metrics. So surprisingly, a lot of clients don't have any kind of meaningful metrics to start with. So I think a very strong recommendation is to look at least at these three that I have here: speed, quality, and operability, but kind of in a holistic view. So what I mean is we might want, and typically, at least in my consulting experience, typically clients want to go faster. They want to deliver faster, get things out in the market faster to stay competitive. So they want to increase speed. That's great, but we can increase speed and at the cost of quality or at the cost of operability, right? You know, if I have long-running acceptance tests, automated tests, maybe I can get rid of them. Then I'll be able to deliver faster, but quality might suffer. So we need to look at least at these three components. And so these example metrics on the right: lead time, failure rate, so how often deployment fails and we have to roll back or fix it, and mean time to repair. These are examples. It doesn't have to be these ones. What I mean is that you need to look at these aspects of speed, quality, operability together. So if you're trying to go faster, you're focusing on that, but at the same time, you want to make sure that you're not degrading quality or operability of the systems. So in the State of DevOps report from 2018, the results are striking between comparing the elite performance, the high-performing organizations, and the lower performers. So these are examples of metrics. So 46 times more frequent code deployments, thousands of times faster lead time, change failure rate 7 times lower, and thousands of times faster time to recover from incidents. So these big numbers make sense if you think that some organizations are going to deliver perhaps once a month, and others can do multiple deploys per day. Obviously, are much smaller changes, but these numbers make sense when you look at that. Again, these are examples. The State of DevOps report, what they did is they've shown that these specific metrics are a good representation of, or make for a good differentiation between high and low performing. So you might want to look at that if you don't have any kind of metrics in place. But anything that is a good proxy for you for determining the quality of your systems, the speed at which you're delivering, and the operability. There's another metric I recommend, and it's really not complicated, even though there's that formula there, but it's basically just, let's compare the elapsed time for release, so the moment we start working on it until it's actually in the user's hands. And from the elapsed time, how much of it, which percentage was actually active work, that we were actually performing activities versus waiting. So it turns out, different studies and experience reports, this is generally around 15% mark, which might seem really low, but it's actually not too bad. So that means 85% of that elapsed time, we're waiting on someone else to do something or to be available. All these kind of dependencies and approvals and etc. that Damon was talking about as well. So the issue is not how long things to get done. Often, when you look at the big picture, is how long things are waiting for someone to work on it or have the availability to work on it. The last pattern for reliable releases is actually just putting in the groundwork, just getting the practices right and getting to know how your systems actually work and how you can improve them. So this is a list of practices. They are explained in the continuous delivery book in some way or another. The reason why I chose this is that typically they require some kind of mindset or approach change to get done. But things like even automated builds in clean environments, so you're not building in the same environment as a previous build, because then you can get false positives or false negatives because of things that were left. You know, that's very basic. But other things like ephemeral production, like test environments. So we talk about testing in an environment that is similar as much as possible to production. But the problem is that often we use staging environments which are static, and where we have multiple teams that depend on this staging environment. And then you have conflicts, and it's hard to keep this environment to be production-like. If we use dynamic environments that we create to run our tests and then we destroy, and we make sure they are as close as possible to production, that gives us a lot more guarantee than, first of all, we really tested in a production-like. We're not affected by other people's tests, other teams. And secondly, we have that capacity to recreate this environment from zero. Health checks are also quite important. This goes into the operations side as well. So monitoring resources, it's important, but finding out that our application is failing or is having problems because our disk is full or because the memory consumption is really high, it's a really bad proxy to find that out. So we still have to go from that kind of alert or that situations and go up the stack and find out, oh, well, actually, why is this disk full? What is writing to the disk? And then see what kind of actions are happening in the application that are writing to the disk and so on until you actually get to the problem. So health checks should be kind of a mandatory thing where you're able to query your application to find out if it's working as expected. So the application itself has the responsibility to know, well, I have enough disk space, I have enough memory, I can connect to the databases that I need and to other services, etc. So it's a much more reliable indication, and it's also much faster to get a kind of sense if things are going wrong if we have these regular health checks on our systems, rather than waiting for monitoring, which is kind of posteriori thing where we're already in trouble and now we're trying to catch up and sort out why we're getting these problems. And smoke tests, fast smoke tests, so a small number of tests that give us a good perception if the application that I just deployed to a new environment, if it's running as expected. I don't see this often enough being put in place, or there's some confusion about what a smoke test is. So it should be really like 2 or 3, 4 tests that execute the main paths in the application to make sure that nothing major is wrong. That gives us very quick feedback if deployment worked or not. Automated acceptance tests with BDD or whatever framework you like to use, but making sure we have a good set of tests that tells us that there are no regressions, that we have a good quality in the application. Having everything as code, this idea of a single truth, so that we can not only have the application code in version control, but also all the configuration, database changes, everything we need to stand up a new application, and also the environment where it runs from zero. And finally, single path to production. And I think this is also often overlooked. And what you see is in many organizations, there's kind of the regular delivery, where you have the pipeline and for regular features, and then you have this kind of alternate path for quick fixes. And when there are issues in production, we're going to skip all that, and we're just going to deploy directly, or what have you, or make changes directly in production. So this is one of those that focusing on having a single path to production, where you say all changes that we want to make to our systems in production go through the same set of activities or through the same path, is really important, because then if you have fixes that need to go out faster, then you need to improve and make the whole path to production better for all kinds of changes, not just the fixes. So again, this is a set of practices that I find quite important for ensuring the reliability of the changes we're making to our applications. But obviously, this needs to be step by step. You can expect to ask a team to now do all this stuff if they're not doing most of it. So you need to learn, you need to experiment, and if you don't have an acceptance test, then let's do one first and see how it goes. How painful is it to create or not? Unfortunately, many times teams don't have this kind of slack to experiment and improve and see how easy or how hard things are to implement. But if you have any way for teams to have this kind of ability to learn and dedicate part of their time to do these things, I highly recommend. So next we're going to look at, we've looked at how do we make the releases safer, that we are more predictable, that we know what's happening. We have visibility. We have good practices in place to understand the health of our applications. But how do we make that also faster? Because that's an imperative today, to deliver faster, get things out as soon as possible. So while our deployment pipelines used to look like this, we're focusing on build, test, and deploy. Nowadays, and with cross-functional teams and this idea of shifting left a lot of activities like security, infrastructure as code, compliance, also getting database changes into the pipeline, it has become a lot more complicated and longer to actually deliver changes if we have all these things which are good in our pipeline, but it makes it slower. And on top of that, we expect development teams, if they're really cross-functional and have operations skills, to run and monitor and fix their applications. But we can't auto-scale people, right? So how do we cope with this increasing cognitive load on the teams? Like, you need to know about not only about development and testing, you need to know about security, database, etc. So the first thing is reduce the bottlenecks in our delivery. So with the value stream mapping, we saw that we can identify, what are the dependencies, where it is time being, where we're spending time waiting for things. So when we have that visible in the pipeline, then we can start to reduce those and focus on the largest bottlenecks first. So imagine this is an example of a pipeline, and here you can see that seems that we can only do one build at a time. This kind of a basic bottleneck we have here, where we have multiple builds in parallel and they have to wait. So obviously we would start here, like make sure we have enough infrastructure and have the procedures in place that we can run multiple or all the builds and pipelines in parallel so they don't have to wait. So that's kind of easy win. But then there are other things. Maybe we have dependencies on manual testing, perhaps, or some kinds of approvals before we deploy to production. If we have those in the pipeline, we can then identify how long is that taking. If I've seen cases where there's one release manager that has to approve all changes to production, or you have a change approval board which meets every week or less, and they have to approve all the changes as well, or any kind of non-trivial changes. So typically the bottleneck then is there. So we can see it in the pipeline and we can look at ways to reduce that dependency. So one way to do that is to shorten the path to production. So what does this mean? I don't know if this is easy to see for everyone, but essentially we have what Jez Humble calls short and wide pipeline. So instead of think of our pipeline as a sequence of steps, of serial steps, we can look at some activities in the pipeline as being optional. So we can say, actually, all changes must go through the critical path to production, which maybe in this example maybe be continuous integration, running build and unit tests, doing the acceptance tests, and then it can go to production. And then we can differentiate, and based on the risk of the different types of changes, we can make decisions about what other activities we need to perform. So if we have a change to the background color of our application, then it could just require the minimum path. I run CI, QA, acceptance tests, and it can go to production. But if I'm making a change, say, to database queries, maybe I want to make sure I run the performance tests before this goes into production. If I'm making a change to some kind of access control mechanism, then I want to make sure I get security deeply involved. So this gives us flexibility and understanding that not all changes and not all features are the same and they don't pose the same risk allows us to say, okay, sometimes those changes can go faster and others we need to make sure we can guarantee that we're not affecting performance, security, usability, all these kind of things. But this kind of pipeline is what continuous delivery is about in terms of it allows you to go faster, but at the same time gives you control to decide when it's the right time to put a change in production. Obviously, if you have real continuous deployment where everything's automated and it can go from commit to production without any manual intervention, that's a different story. But I have not seen any of my clients be able to do that. Another pattern that I like to call continuous pruning is about getting faster feedback and thinking more deeply, let's say, or taking care of our tests in a more meaningful way. So there's this quote from Gojko Azic where he says, a test is only meaningful at two moments. First time it passes, because we know we had a failing test and now we made changes and it's passing. It's doing what we expect. And when it fails again. But if you have tests that are green for months, years, and they never turn red, are they worthwhile running every time for every change? Or maybe we can put them in a kind of separate test suite which we might run perhaps once a week or nightly, just to make sure that it's still working, but it doesn't need to be in the critical path to production. So with this high-tech pipeline design that you see here, what I see often in clients is they have a pipeline like this. Continuous integration runs fairly quickly, and then let's run all the tests, all the automated tests, BDD or what have you, all together in this big box and wait to see what happens. We'll come back in a couple of hours or however long it takes and see what happens. So that's very slow feedback, right? What if we at least separate the new tests that are testing the things we're changing in the application versus the regression tests that are making sure we're not affecting the old code? Because what's more likely to fail are the new tests, because that's what I'm working on. I'm making changes, and until they all pass, I'm not ready to go to production. So I want to get that feedback as fast as possible. So if all my tests pass, then I will eventually run the regression tests. And maybe even better, even faster feedback if we apply this idea and we have different kind of levels of likelihood that the tests will fail. So I might want to run first actually the tests that failed in the last pipeline run, right? Because that's what I'm actually working on right now, and I want to know if I fix them or not. Because if they're all in that big box, and by bad luck, those new tests that I care about only run at the end of this big box, then it's going to take a long time to get feedback. And so on. So I might run the ones fail first, and the new tests that were passing, and then maybe I have a bigger release tests, and then regression tests. So it's just the idea of separating. And actually, in terms of execution, this is the same, because the time of executing each of these smaller boxes is kind of negligible compared to the whole times the duration of the whole test. So this takes more or less the same time if it all runs as this, right? But we get much faster feedback on the things that we care about right now. And the other thing, by the way, here, when you have this kind of separation of more fine-grained activities, you can also apply that other pattern, that short and wide pipelines, where we might say, actually, I don't want to run the regression tests every time, perhaps. Maybe I just want to run that nightly or weekly to make sure that there's nothing that I didn't make any unexpected change that caused an issue. It depends. But it gives us the flexibility to say, well, actually, this shouldn't be in the critical path. I don't need to run this every time. And this kind of a bonus pattern here, and Damon already alluded to that at some point you need to think also about teams and interactions. So this is strongly related to how our release process works and what are the bottlenecks and the problems. So that DevOps topologies website I was talking about, that was created by me and Matthew Skelton, you can see different kinds of ways that teams might interact. So to the right, you see kind of more cross-functional team with dev and operational capabilities. Those kind of teams that are able to, like at Netflix, that are able to not only develop, deploy, but also run and monitor and fix their systems as quickly as possible. But there are other ways to organize. The point is to start looking at this and start identifying why can't we go faster, or why can't we be safer in our delivery. And finally, I'm going to talk about this idea of sustainable delivery. So this is kind of misunderstood or not very clear. What does this mean to deliver changes in a sustainable way? So to me, it means, first of all, we need to look at our delivery as a system. It's no longer just a CI/CD tool or a couple of tools that I need to use. It's actually a system if you come to think about it. And then putting in the effort to treat this system as it deserves or as it needs to be reliable and of high quality as well. So what does that mean? What I see oftentimes is in organizations where production looks like this, all the lights are on, we have our monitoring alerting, and we're making sure that we find out issues as soon as they happen, hopefully. And then delivery is kind of, it works, so don't touch it, because if we touch it, it might fall, so just leave it like that. So there's not a lot of care into making the delivery system actually reliable as well. So delivery system, what I call a delivery system is a composition of tools, essentially. All these CI/CD, third parties, plugins that you might need, but also the actual pipeline definitions, the repositories where code lives, and also where we store artifacts, and obviously the infrastructure, unless you're using a SaaS tool, then you need to care about infrastructure as well. So the delivery system, on one hand, it's good because it's decoupled, right? If you're putting together a tool chain, the tools were not explicitly made to work with each other. So they should have good APIs and good communication mechanisms, so they're not coupled. But at the same time, it's a lot of integration between tools, right? There's not a lot of code of our own. It's mostly integrating these things together, make sure they work with each other. So it can look visually a little bit like this. You might have your tool chain, perhaps with containers, with Docker images, or what have you. And you have all the configuration for these tools as well as code, so that we can start up a delivery system from zero, ideally. We know which plugins we need. We know how the tool should be configured so that it runs and does the things we want it to do. And then we have the actual pipelines running, and the application code, and the infrastructure, and finally artifacts that come out of the pipeline. Obviously, this is a super simplistic pipeline, just to show you an example of how the tools interact and how the whole delivery system looks like in kind of a visual way. So if this is a system, then we should be caring about the operability of this delivery system as well, right? So caring about the same things that we do for our production systems. Hopefully, so it should be available, should be a minimal downtime in the delivery system, because we need to deliver faster. You've seen how often high-performance deploy changes. It can be up to hundreds of times per day. So the system should be available. It's no longer okay to say, well, we need a 2-hour, 3-hour, or half-a-day maintenance window to update to a new version of Jenkins, or install some new plugins and manage dependencies, etc. That's kind of no longer acceptable to do. So we need to think about other ways where we can ensure availability and reduce downtime. It should be scalable. Like we've seen before, we shouldn't have this basic problem of pipelines waiting to run. It's just a matter of infrastructure and scaling. It should be monitored, because there are problems in the delivery system which are not of the pipelines themselves, of the running pipelines. It's the system, it's the tools that are no longer communicating correctly. Perhaps we updated a tool to with a new API version that is not what we expected, what have you. There can be all sorts of tooling problems in the delivery system. And when we have problems, we want to recover as fast as possible. So we should have also mechanisms to diagnose what actually happened. And because it's a strongly integrated system, it's not always trivial to find out the problems. So essentially, the pattern is just one here. It's just kind of a large pattern of treating your pipeline or delivery system as a product. And this is actually what I'm going to dig into tomorrow in my workshop. But essentially, at least look at this kind of attributes for your delivery system and how can you ensure them. But there are other aspects of treating pipeline as a product, like knowing who your users are. We're no longer at the state where only developers and perhaps testers use the pipelines. Other people in the organization need that kind of visibility of what's happening with our changes, where are we at, what do we need to do next. Business people, release managers, what have you, people that need to have insight into the pipelines as well. So some of the practices that I'm going to dig a bit more tomorrow include using immutable infrastructure and blue-green deployments. So that means instead of we have a delivery system running that our development teams are using and other teams are using to make changes, we should be able to create a new version of the system if we want to update it. We create a new version in parallel with the new tools or new plugins or what have you. And at some point we say, okay, this new version is working as expected, and we can now make the shift, this kind of blue-green approach, where we say we're going to now start redirecting teams to the new version. And obviously we might need to wait until whatever it was running finishes, and then we make the switch. But this minimizes as much as possible the downtime and that window that we used to need to be able to make this change. Because if that window of 2-3 hours to update, that means teams can no longer get feedback for 2-3 or more hours. And so when it finally comes back, they have all these changes piled up, and then they are going to have to find out how these multiple changes work together in their application. Monitoring, alerting, already talked about. We need to have some ways of seeing how the delivery system is performing. What are the problems? Are we running into memory problems, file system usage? That's the typical one here, because if something goes wrong, you might be quickly filling up file systems. In the delivery system, we should use aggregated logging, so making sure we get the logs from all the different tools that are in our system and aggregate them so that we can easily query for problems. So actually with pipelines, you typically have a pipeline ID or a build ID. That's actually quite useful, because you can then, if you aggregate all the logs, you can search for this ID and see what the different tools, how the different tools performed and what did they do in relation to this build ID or this pipeline run. Because in delivery systems, when you have a problem, typically it's coming from not just from one tool, but from the combination of 2 or more tools. Pipelines as code, so we don't make manual changes in the CI/CD tool to change how the pipeline works and what are the steps and so on. We should have everything as code. I think today all the main CI/CD tools allow this. Some have kind of poor kind of error handling when you have an issue with the pipeline definition. It's not always clear what is the problem, but they all support it. And this allows us also then to, again, be able to recover, for example, from a disaster in our, imagine the whole delivery system is gone. We can recover quickly by having all the pipelines actually defined as code, besides all the tool chain, the images and the configuration, everything as code. And finally, auto-scaling, like I mentioned before. We shouldn't, it's just a matter of being able to scale our infrastructure to cope with high peak. If you have a lot of teams working parallel, that you have a lot of builds and pipeline runs, you should be able to handle that with auto-scaling. That's it. Thank you very much. I'm available for questions.